Good morning, and today I will explain how an Ollama language model can be deployed using KServe and MinIO. The main idea is simple. Ollama runs the model, KServe manages the services on Kubernetes, and MinIO stores the model files. I will first explain the role of each tool, then show the model loading path and live request path, and finally summarize when this setup is useful. Okay, so each tool owns one part of the serving stack. What it means, it means that these tools are not alternatives. They solve different problems while serving our model. So Ollama is the inference engine. It loads the language model into CPU or GPU memory and provides endpoints such as the native generate API and OpenAI compatible chat completions. Second, KServe. Basically, it's is our service manager. It tells Kubernetes how to create the model serving pod, expose it through networking monitor it and scale it. And third one is model storage, that is MinIO. MinIO is a model storage. It provides an S3 compatible place for model weights, okay, gguf files, adapters, or different model versions. In a simple way to remember, this is Ollama is the cook, KServe is the manage the restaurant, and MinIO is the warehouse of that kitchen. So MinIO loads the model before traffic begins. What it means? It means it's an important distinction. During normal inference, a client sends a prompt to the KServe endpoint. KServe routes the request to the Ollama board. Ollama runs the model and sends the generated response back. MinIO is not part of every prompt and response. MinIO is mainly used when the service starts or when a model version changes. What it means? So basically, KServe inject storage initializer that reads the storage URL, download the selected model files, and place them in the path, that is anything like MNT model something. After that, Ollama still needs to import or register the custom model. For a gguf model, this is normally means a model file pointing to the gguf file and then running Ollama create. So mini MinIO supplies the files, but Ollama must prepare them for inference. I think you got the point. What happens in whole scenario when a request comes through the service path, and Ollama import the registered model and modify the pointing and give us a prepared output. So deployment happens basically in three clear stages. Okay, what is stage 1? Stage 1 is the storage, stage 2 is deploy, and stage 3 is serve. So firstly we have to upload the model file in MinIO. Okay, MinIO is a basically bucket, S3 bucket, or we can say it's a storage with which we can store model bits. Then second stage is deployment. We give KServe the MinIO credentials. What it means? It means we will make authentication process between MinIO and KServe, okay, by the credentials. So then what we will do? We have to define a custom serving runtime that uses the Ollama container and create an inference service that points to the module location. When the pods starts, the storage initializer downloads the files. Okay. Stage 3 is serving. So it means a startup command runs Ollama, create a custom model, or Ollama pull for a model from the Ollama registry. The pod should become ready only after the model is available. Clients can then call Ollama's native API or an open AI compatible endpoint. If the system requires the strict KServe V2 protocol, we may need a small adapter in front of Ollama. So, how we use this stack for control and simplicity? To conclude, this combination is useful when we want self-hosted model storage, Kubernetes based service management, and simplicity of Ollama. But we must check three things before production. First, the client API must match the endpoint exposed by Ollama, or we need an adapter. Second, downloading and importing a large model can create a large cold start. So, caching or persisting storage may be needed. Third, the model must fit into available CPU memory or GPU memory. For every high throughput case serve, optimize LLM runtime such as VLLM based path may be a better choice. The final sentence, remember, is MinIO stores, KServe manages, and Ollama generates. Okay, so thank you. For further videos, detailed videos, follow me.